let's actually get into the meat and potatoes of tonight, which is we're going to take this apart and start designing a set of triggers. And that is kind of intimidating because we're about to void our warranties. I cannot afford to replace these again. Man, first time, guys. First try. You see it right here. I guessed the correct hex size. So, let's see. Let's move over to the workspace over here. You guys for a second. The microphone came unplugged as I was moving over here. Guys, at the sky for a second. And tilt you all the way down. All right, there we go. Oh, look at that. That looks downright professional. Yeah, Wills, you said it. Goodbye warranty. We're going where no man has gone before. There's probably not too many people that are actually ripping apart their Virpils. So that might be a little more valid to say. There's probably some Loctite in there because it has that like build up in tension and then it like snaps free. I'm gonna knock these out. Looks like they are all the same size. That's good to see. That makes things a little easier for me. There's more screws on this side. Oh, that one's a different size. That one's longer. Okay, so let's set that one off to the side. That came from here. Here, I was wondering if this would come free. It did not. There is something else that's holding that in. Relief. I think the next ones are some teeny tiny Phillips head screws. This is the new Transmagic Screwdriver from LTT Store. They did not send it to me, so not sponsored. I don't care if you buy one. It is a decent screwdriver. One of the things that I do feel though is this plastic is a little slippery. So when you really need to wrench down on something, it's a little tough to get the force that you need out of it. Two teeny screws hidden underneath this cowl. Looks like the Predator head. Imagine if we did all the work of unscrewing those screws and then it turns out that all we need to do was these two little ones. How funny would that be? Those are different sizes. Okay. So here is your look at the flip trigger. So we have a spring inside this transparent plastic that's pushing against the lever, and then it has different flat positions, basically lock it into place. And then when it's in the down position, hold on, actually that would be the flip down position. Missing something here because oh, okay, yeah. So under normal circumstances, I guess you don't actually reach this region back here where it rests on another flat. Oh, sorry. So this range of motion is where you have your triggers. Plug that. And I don't see. How is that working? Oh, I do see a magnet. I think that might be underneath. See that silver section right around the rotation axis? Yeah, that's a clearer shot. So that looks like it's a magnet. It is a magnet. Okay. So I would guess then that there is a Hall effect sensor built into the circuit board. And then it's also clearly doing the LEDs. Oh, okay, so there's more screws holding this part on, but looking at this inside here, it doesn't seem obvious to me that, oh, okay, there we go. It's actually coming apart. There we go. Hey, I finally made it while you were taking apart these. Welcome, Wesh. How you doing? I don't think I've seen your name in chat before. Is this your first time jumping in? If so, welcome. Always happy to have new people. Oh my gosh, guys. The more things change, the more they stay the same. Oh, so that's actually something that we've been talking about, Wesh. Yeah, I don't like the pinky button either. I've got a plan in mind for how to fix it. It is something that we're going to look into. I want to make an extension for it. So that is something that is coming down the line. But do you guys see what I'm seeing here? This is the exact same mechanism as what is inside the VKB for how its trigger works. Let's see if I can get the light to catch well. Maybe I'll just have to point to it. I don't know if I can get the camera to show it super well. Right here, there's a spring, and that's resisting the motion of the trigger. But when you compress it, it has this little plastic plunger that pushes that first blue button, right? And then beneath that, there's this little foot that after you pass the first button, it compresses a little more, then it presses the second button, that little foot extension. And you know what that means, guys? It means that making this trigger is going to be super. I was worried that I would take this thing apart and I would just see this like super complex assembly and that I wasn't going to be able to reuse everything, but this uses the same mechanism as what we're used to seeing in other sticks, which means that everything that we've learned on the VKB does in fact apply here. So that is possibly the best news you could have given me. I'm going to go ahead and read through these guys on though, because it doesn't look like there's actually any benefit to having those out. Them out. Put them back. That's love your mods for the VKB though. That's great. I love the build quality of these, but the pinky is totally useless. I don't know if my pinky is too short or what, but I can't wrap it around. No, if you go back and watch this as a VOD, you'll see that I started off the stream complaining about the ergonomics of this stick. So you are certainly not alone there. I'm not the biggest fan myself. Did any of you guys happen to see how this was installed? I knocked it out. The heck? Oh, it's keyed. That's wonderfully frustrating. this right? Okay, well, I will figure that out later. It's not important right now. If one of you guys can go back and watch, tell me, was this spring on top or was it underneath the lever? Does it go in this part or does it go in this part? I am. I didn't see that come out. So, one thing that I am kind of sad that we'll be losing is we currently have a metal trigger. I wonder if I can get PCBWay to sponsor a video and print one for me, because it would be really cool to keep the metal feel of the trigger. But obviously we're not going to get that with my resin print. One thing that is different about how Virpil is approaching this versus how VKB does it, the way the VKB stick works on the inside is the spring actually grabs onto the button post, where this time we have a little bit of a plunger that pushes against it. I don't think there's necessarily an advantage either way. But it does mean in the case of our mod that we have to account for a little bit of extra movement that's possible around the sides. I'm thinking though that maybe we can make our own little cup, just go around it, because the button doesn't move all that much, right? It has all this extra height to the button, but it doesn't use all of that. It only moves less than half a millimeter. I think we could probably make a little topper for it and modify it that way. So let's go back into CAD. Like outs. How good did I do on guessing the position? Not terrible, actually. Okay. Switch back to our main screen here. Let's full screen this. And I'm just looking at how it installs to make sure I'm not missing anything. But dare I say we might actually have a little bit more space for the mod in this stick. The other half there as well. So, I mean, the two faces that it rides on, there's really nothing there as far as like lips to watch out for. I think we'll actually have an easier time making the mod for these sticks than it was for the VKB, which is fantastic, man. Basically, as long as I respect the envelope of this trigger, be good. So, first step is we need to get a drawing of the trigger. So C for circle. And then we've got an arc above that. I think we have another arc here, a longer one. And this pin is a little greasy. Getting some grease on my fingers, trying to keep things clean. 3.96 millimeters, so we can round up to 4. And this top section looks to be centered around the pin. Looks to be an additional 4 millimeters from that. The Shift O is for a concentric mate. And then we can do a distance between these. That to 0.4. And then we make these construction lines coincident with the center point. We're going to push those up a little bit. Right now, I am honestly, I'm just guessing, right? I'm getting an approximation that I will have to verify later. But if I can get this printed or started printing, I can test the fit off of that, and that does a lot to confirm these initial suspicions. So anytime you're working on your first prototype, you just want to get it done as quickly as possible, so that you can start learning from it. It does not need to be perfect. Fail fast and learn from it, right? And I'm now reconsidering this section. I think that those might actually be the same radius. So that. All right. Ooh, I actually do have some radius gauges. Oh, I'm gonna grab those real quick. Totally forgot I have these. So these are radius gauges. It's just a bunch of thin pieces of metal with different radii punched out of them. Using them, very simple. You just find one that you think is close to the right size. Probably going to be these, if anything. And you hold it up against your part, and you look for a light gap. If it touches in the middle but not the edges of the leaf, that tells you that your leaf is too large of a radius. And if it touches on the corners but not the middle, that tells you that it's too small. And the bad news is it's bigger than my biggest. So at least that backside is. Let's see if we can't get a better approximation for the top, though. Right now we have it set to 8 millimeters, so we can confirm whether that's correct or not. And it looks like I'm off by quite a bit. Actually, no, that would be 6. So let's try 6. Another set. So there's no way I'm going to be able to show this to you on camera. But this is with 6.5. That's too big. And 6 looks pretty dang good. So my previous approximation was pretty accurate then. See if we can figure out that front edge though. That's much too small. Different size. Touching corners means that we're still too small. We're getting full use out of all of our measurements here. But that's frustrating. This one's clearly too big. Check 6.5. 6 is clearly too small. 6.5. 6.5 is just I think that's actually just a little too big. Yeah, because the corners aren't touching. The middle is. So this is 0.625. That's the best approximation we can get with the limitations of these tools. Now, will we get lucky and be able to check finger groove? Those ones are definitely too small. We do have another scale up. We might get lucky. Dude, that is perfect right there. What is that? 22. 22 millimeters. So that's the front side. A 2.25 is too big. We're measuring this where I have it as 1 millimeter right now. I want to check that. But it's looking like I was probably right. Yeah, I'd say I'm probably getting pretty good at guessing some of these dimensions. That is exactly one. This backside is tough to say. Well, definitely a little smaller. I don't have smaller gauges though. I'm just going to assume that it's half a millimeter. And let's see here. We can get a depth on the front edge to where it will hit the foot, which is very nice to be able to do. This is a much simpler part geometry wise than the VKBs were, which I really hope that's going to help speed up production time a lot, because I know lots of people want this. I want to get it on my own sticks. I'm sick of having the dual trigger. I want my split triggers back. So let's hope that we can get this cranked out quick. So from here, nope. I said from here is 16.5 millimeters. Do our tangent to that. Measure tangent. Tangent. We can measure the overall height of the trigger, like so. Is also very nicely squared off, so it's a sure measurement, which always feels good. That is now this next part I am guessing a little bit. It looks like this curve is tangent to a line going vertically from the pivot. So at least for our first test, we will assume that to be true. For some reason it's fighting me on that. It should be fine. There we go. So I don't know if you guys can see the same thing that I see, but it seems like it kind of leans forward a bit. So I'm envisioning a line going through those. Let's see, I can check that somewhat. So yeah, I think there is a implied tangency here. I was probably a little overzealous with that part. Let's just simplify that a little bit. Make these the same point. Tangent. And redo this dimension. Do it this way. We'll create some construction lines so that we have a little better control over everything. That tangent will make these coincident, and we'll set the length of this line to 6. And see, that's going to measure it the same way that I was measuring it with the jaws, so I'm more confident about that. We can make these coincident just to clean up those tails, get them out of the way. Doesn't really affect anything though. And I don't have a range of gauges that will allow me to measure this back strap well. It looks though that it starts off tangent to this line down here. And one thing I have learned is it's usually a pretty safe bet to assume some kind of logical reasoning when you're trying to reverse engineer a part. Like, someone at Virpil had to design this part, right? Unless there's a reason for it, you're not going to find like random decisions being made. There's usually going to be some kind of thought behind it where it's like, this will fit. This is a nice round number. So it's usually a pretty safe bet to do some rounding, especially for a first prototype trying to reverse engineer something. I find that that's generally pretty safe to do. But if it looks like it's tangent, it's not going to hurt to check and see if it is. We're just going to print a version of this and see what happens. I don't know if I'm making sense there. If you're trying to reverse engineer a part, you need to remember that it was designed by someone who had to go through the process and constrain every piece of geometry that you see, right? So they're not going to waste their own time trying to make things complicated. That's probably a better way to look at it. If there are easy ways to do something, it's a pretty safe bet that they picked those easy ways unless there was a reason for it being more complicated, right? Like if you're looking at a coolant path, right? Like you need to increase a lot of you need to increase turbulence, right? So there's going to be extra geometry to add turbulence to the water flowing through it, right? So there are going to be complex paths there. But if all you're doing is designing a pipe that transports water from point A to point B, there's no reason to have it do a snake zigzag pattern because a straight pipe works just fine, right? So yeah, it was designed by someone who wanted to be able to machine it as cheaply as possible too. That is also very true. This is a aluminum part. It looks like there is a sprue mark, so I would assume these are cast. Just barely make it out. I don't know if the YouTube compression is going to give me mercy there. There's a sprue mark just above where the spring makes contact. So I would assume that this was cast, but the mold still needs to be made. And you need to design this to work with a mold. And so you're going to be limited by the kinds of shapes that those can pull off. Design for manufacturing. That's probably the summary there. So now we need to design that little foot. Thought I was not there. We're going to call that line horizontal, make these guys tangent to each other. And then we can get a depth measurement for how far it extends. And that looks to be 3.5 millimeters. I really wonder how many they actually manufacture worldwide. A couple thousand. You know that's one of the tough parts, because if we are talking about an injection molded part or a cast part coming from a mold, I mean, regardless of injection molding versus casting, like they also have their cadet, which is not a aluminum part. That is injection molded. Anytime you're using a mold, though, you're talking about a pretty significant investment for the mold itself that typically doesn't make sense for products under 10,000 in quantity, is one of the rough estimates that you'll see, and that is a very rough estimate. There's a lot that plays into it that is way beyond the scope of today's video. But just as like a textbook reference, like if you're making 10,000 of something or more, that's when you tend to want to look at doing molds. So I would hazard a guess that they're probably doing at least that much, right? And this looks like 0.05 from before at 1. I'm going to set these two equal to each other and these two equal to each other. And I don't have a protractor in this house. So I'm going to guess that that is 120 degrees. Then hold it up and see how close it looks. I think it's 110. Oh yeah. Yeah, that's 110. Feel pretty good about that now. So now we can do our first extrusion. We're going to do just this face. And it is, make sure I don't have any error, 11.998 at the widest. Oh, checking a couple different spots. Oh, thought I was, or I was not. Do that as a symmetric one so that it goes equally across the planes. And we will show sketch 1 again, do another extrude for just the little foot piece, 4.95. That is symmetric as well. Now let's see if we can't get a estimate for the curvature of the trigger. Touching on the corners means we're too small. That's 8. Up to middle means too big. My between side looks really good. Size. Okay. Best way to achieve that, though. Okay, I think a brown question. Okay, this will be. Let's see. I'm going to create a plane. So when you're creating a plane, you have several different options about how you define it. This time I'm going to do a 3-point plane. I'm going to select that point, and our origin. And then on this, I can bring in this line as a reference. I can do, I don't want to do it that way because it drew a constraint that I didn't want. And then once I set these two lengths equal, that's one way to get this to be in the middle. Another way, though, is we could also select the origin, said the origin, and the pivot point. You can set it to the middle that way. But then we have this point out here that comes from our side sketch. And we can create a construction line through that. And if we revolve like so, we can trim the front face. And you see how it creates this kind of V shape here? That same V shape is present on the trigger, which is a pretty big clue to me that that is what they did. And then they probably hit it with some secondary fillets. These could have been added intentionally, or they could have been a result of the powder coating process. Let's see. I think those get the same. I'm going to uncheck tangent propagation. I'm going to try to manually select everything because I don't want this to extend to these back edges. I want to put it everywhere that I think the 1 millimeter radius was applied, but only those areas. And I'm actually rethinking it there as well. Do that. And these ones I'm going to define as 0.5 millimeter. That looks more accurate. I'll also do that. It's not liking it in that operation. It's not probably that. Okay. That is the rough outline of our trigger done. Then from our front plane, we're going to draw a rectangle. And if you do R, that draws a centered rectangle. If you do G, you can do corner to corner. So I'm actually going to do R because then I can have it automatically reference the origin by lining it up below, and that will automatically center it. And I am getting that this thickness is 1.4 millimeters, And because we are referencing the origin, it automatically applies that on the other side as well, right? That has to be the same distance. Then we can measure across the bottom. I'm getting that is still 1.4 millimeters. And what I'm noticing is the top of the foot lines up with that same point. So I think I have this located a little too low. I'm going to go back and change that. I think basically this tangency or this coincidence is not it is actually that. Actually, let's try it here. There we go. That's a little happier with that fillet. I can actually simplify that by rechecking tangent propagation, clearing these out, and just selecting 2 lines. And it'll apply it to all of them at the same time. So it's better to do that because if I need to go back and change this in the future, I don't have to go through a big selection. So it's better to have it simplified whenever you can. Back into sketch 3, you can measure to the bottom of that face. I'm getting 1 centimeter. And then what we're going to do is we're going to do an extrude. We're going to give it a starting offset. We're going to reverse the direction of that start. And then we're going to have the end position be up to face. We're going to select the front face. And then we are going to set a offset distance of 0.2. Fighting me. Is that back? See, it should just be matching up to this face right now. It's not. So something about that geometry is confusing it. We could also go blind though, because it does look like that inside is flat. So we set that to remove. Want to make sure that the amount of cut makes sense. That looks pretty good. we can double check it by checking the depth. And it does look like there is a chamfer here. And I am going to have to guess the measurement there. I'm going to assume 60. And then on the part, I'm going to measure this distance right here and see if that lines up. I'm measuring 6.96 millimeters. The digital version is 7.02 millimeters. That's probably just the difference in the coding. So, dang, I'm good at this. Sometimes. And then the cup for our spring looks to be perpendicular to this face. Just barely get the teeth in there. Looks like that is 1.4 millimeters from bottom edge. And it looks to be, can I get in there? Barely. 6 millimeters in diameter. Another way we could get close to that measurement is to actually measure the spring. The interior diameter of the spring is 6.35 millimeters. So 6 millimeters is probably a pretty good guess for the size of that cup. And the inside diameter of the cup is 3.5. Okay, I can't quite get my tool in there to measure it. So we'll get an approximation by sticking something else in there. In this case, an Allen key. And we're getting 16.37 versus 20. So I'm going to assume that this cup comes out by 4 millimeters. Like so. And then just to make everything play a little nicer, we're going to give the slightest of chamfers, fillets to those edges, as well as to the corners of this box. Like so. That makes everything look a little more finished. Actually apply that too. Why not? Okay, so that is our recreation of the trigger. Now I need to get this printing so that I can double check my measurements. We're not going to get the full split trigger designed tonight. That is going to take quite a bit more time. But this is a fantastic start towards recreating the original. If everything on this works as intended, then that tells us that we're really close, and we can then use the measurements that we have constructed here to base our split trigger on that. Right. So this is all about giving us a solid foundation to start from to make sure that everything is as we understand it. So let's go ahead and name this. Then we're going to export this as a 3MF. We're going to put it in the new Verpal folder. The first thing we put in here, pretty exciting. Then we'll open this in Orca Slicer and save it. So the reason why we do this is, for whatever reason, the way that Chitubox, which is what I use for my resin printing, however it interprets a 3MF from Onshape, it doesn't use the same scaling as Orca Slicer and other softwares like that. So this is just a quick workaround to be able to get things to show up the size that you expect them to be in the slicer. If you've had this issue with any of my files before, I've sent you these same instructions when you've reached out to me. Just open the file in Orca Slicer, immediately save it. Don't do anything else to it. Just literally open it, Orca, save it, done. All right? Then you can go to Chitubox. And it will open with the correct scale. I don't know why it's like that, but it is what it is. I'll update that later. There we go. So, looking beautiful. Look at that. So pretty. We're getting some weird faceting on that front face. That's kind of interesting, isn't it? Probably doesn't affect anything, though. And it might just be a visual thing in the slicer. Everything else looks super polished. I'm pretty happy with that. Make sure you select it. Then we need to add our supports. Oh, actually, sorry. Before we do that, orient. And then I always just want to check, make sure everything looks like it makes sense. I'm thinking that this inside pocket is probably going to cause some issues, so I'm going to adjust it myself a little bit and make sure that we get some more support on that inside pocket to make sure that everything there forms well. That'll also make sure that we don't get any support on the finger surfaces, which is what I always recommend when you're printing any of my triggers. Try to keep those finger surfaces clean so that you don't poke your fingers. Going to do the auto support, apply. Check that, make sure it looks good. And honestly, that's all I ever really do. For the kinds of things that I'm making, Chitubox does a pretty good job. So I don't find that I need to change that all that often. So let's slice it. Do a quick check, make sure everything looks good. We don't have any huge jumps in area from layer to layer. This looks to be within what we would deem acceptable. So let's send that. Oh shoot! You know what? Um, Gosh, I didn't think of this before. I got a new router specifically for my computer and the Quest headset. I'm not on the same network as the resin printer anymore. Shoot. I'm not on the same network as any of my printers. Okay, I need to go change the network settings on that printer. I think it'll be okay to have, well, is it going to reach from here? It's going through a brick wall and then it's across the house? Okay, that printer down there has a USB stick. I'm going to go grab that. I'll be right back. We're going to do things old school tonight. All right, back to the dark ages. Got the USB stick. We'll just save it instead to oh, you know what? I've never actually put anything on this thing. So let's just create a file, I guess. Here. Uh, Purple. Oh, look, it's there. Yay! Okay, so that's good. Let's check. All right, now that's loaded onto the USB stick. So I will go plug this back in. I'll get the print started, so I'm going to be off camera for a minute. When I come back, I'll have an estimate of how long this will take to print. And then we might be able to test the replacement trigger tonight. Depends on how fast it goes. I'm guessing, well, it probably said in the software, didn't it? Oh, yeah, it says it's going to take an hour, just over an hour. So we'll probably still be online by that point. So, yeah, we might get to test this then. I'll be back. All right, we're back. So that's going. It's 10:29 right now. So 11:45, we'll go and check that and get it into the curing station. Oof. Oof. That's some nasty burps. Alright, so here's the thing that continues to frustrate me about T2 Box. This is like my only complaint of the software. I close it. Oh, hit the wrong button. I close it. I tell it, no, I don't want to save because we already saved it. I don't care. Guess what's still open? T2 Manager. It doesn't close. And so far as I can tell, there's no way to make it do so. If you hit the X, it's still going to stay open. So, yeah, I really wish that they would change that aspect of it. But it is what it is. So that's where we're going to stop on the production of the triggers for tonight. This will give me plenty of information to work and test on. So I don't want to get too far ahead of myself. You know, like we could start drawing our split trigger, at least the sketches for it, but there's not much benefit to doing so. What I should do, because I'll need them for later, is put my joystick back together. And I think I'm going to have to open up my own stream. And because none of you guys went and watched it back for me to tell me what I was doing wrong. I need to find a point in the stream where it was still put together. Aha, okay. Okay, that does look like it's beneath, right? I think my hunch was correct. That leg goes up. There we go. This is a bit fiddly, isn't it? Who would have thought? Oh! Nope, don't got it. Okay, if you do this mod, don't let this part come out because this sucks to put back in there. Okay, that feels right. Alright, I know you guys can't see anything. It's really not that interesting, I promise. Just struggling to get everything put back together. Very carefully. Two halves back on. Um, think about the factory workers who assemble this every day. Every day I wake up, I am grateful that I do not work in a factory. This kind of stuff would be so aggravating. I am always grateful for people that are willing to do it because it's not me. Oh. Oh. Go to your home. Why don't you go to your home? A little washer there? Is that preventing it from going in? Is this the kind of thing where if I squeeze it? Oh, man. Oh, I don't want to break my very expensive sticks. Okay, I think I can... I think, though, that this is well enough secured that it's not going to come undone. Okay, I'll put it back on. There. Just don't stare at my junk. By that I mean that stuff over there. Okay. Something just fell. Oh, okay, I thought that screw was in. It wasn't in. I don't want to be rubbing. Okay, so the frustrating part, that hole is keyed. This shaft is keyed. Getting those to line up is key, but not easy. Okay. All right. Okay, that is definitely in. We're screwing that. Oh my gosh. Okay, that is definitely in. All right. If you are trying to do this at home, don't take out this screw. You don't need to take out that screw. If you do take out that screw, you will be very, very sad. Bounced off the desk, onto the floor. Oh. Whew. Thanks for hopping in, Cam. Good to see you. Still waiting for a text, by the way. Um, okay, that sounded like a positive click back into place for everything. All the screws are the same size, except for this bottom one on the back. I thought that there may have been some Loctite, but I don't see any evidence of those actually on the screws. So the other explanation is that they, I don't know, maybe they just have a torque spec. They probably put it together with a drill. I would hate to think that someone is doing this all day. Shoot. Crap. I can't remember if there was a connector. There's got to be a connector that I'm not remembering, right? Because there's these buttons on the shell I just added back in. They've got to connect somehow. What am I? Oh, okay. Okay, so I didn't actually skip anything, but let's not lose parts of our trigger. Take that off now. So they actually have a pogo pin connector that connects the two halves. Do you guys see that? That's how I didn't remember it when I took it apart, because nothing to take apart. That's a neat solution. Pogo pin connectors don't have the highest cyclic lifetime, but for a situation like this where you're really not going to be taking it apart all that often, um, that's a pretty good way of keeping things together than like a ribbon cable or something that a user might yank on. So yeah, I like that quite a bit. That's a cool solution. So once it's pressed into place, those pogos are all touching, and that's sending the electronic signal between the two halves for, in this case, the lights and this button combo up here. Yes, nothing to get pinched between the clamshell. Exactly. All your wires stay in place. There's no reason to take those out. Right. Then we grab our predator head, and you do actually have to take this off because it has a screw on either half of the clamshell. There's no way to get the shells apart without taking this off. So I was correct there. There's probably a whole build guide online too, but I like to do things the hard way. Gosh, kind of frightened me here. I think it's going in now. And I have to like push everything together. Okay, they're tiny screws, so you don't want to go too hard on them. Okay, these two are tricky to get in. They're teeny tiny. Go right up underneath the cowl. And you kind of have to like pinch everything together or to get the holes to line up. There we go. Now they're going in. Whew. All right, back together. Together again. It's good to be together again. Putting it back on the base always gets me a little nervous because man, just it's like get this connector lined up and then hope you plop it down right. There we go. I wish they had a better method of connecting the joystick to the base. That SVHS ADB, is that the name of the connector? Probably, right? SVHS/ADB. Yeah, this thing kind of sucks. I do not like this connector. Well, okay, so it's not exactly this one. It is a little different. Because it has 3 pins and 2 pins. Um, oh, I can't get distracted by that. I'll spend all night looking at connectors. But yes, I agree that that design kind of sucks. Then make sure that everything is straight.